Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. I direct the actuarial program at Illinois State University, and information about it can be found at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, go to smarturl.it/help-ISU-actuary. This is the problem for today. A student takes an examination consisting of 20 true-false questions. The student knows the answer to n of the questions which are answered correctly and guesses the answers to the rest. The conditional probability that the student knows the answer to a question, given that the student answers it correctly, is 0.824. Calculate n. We begin by labeling the events. Let C and K denote, respectively, the event that the student answers the question correctly and the event that the student knows the answer. So we are given that the probability that C given complement of K is 0.5, and the probability of C given K is 1, and the probability of K given C is 0.824, and we also know that the probability of K is n over 20. And then we can write that conditional probability of K given C, which is 0.824, as probability of C given K times probability of K divided by probability of C given K times probability of K plus probability of C given KC times probability of K complement, or KC, standing for K complement. This is a form of the Bayes theorem, the simplest one, or it just follows from the definition of conditional probability, because if you write probability of K given C as probability of K intersection C divided by probability of C, then the top in this ratio that we see here is probability of K intersection C, and the bottom is probability of C. And then we know the entries in here. The top is 1 times n over 20, and the bottom is 1 times n over 20 plus 0.5 times 20 minus n over 20, or 1 minus n over 20, where you would then put it in parentheses, but that's the same thing. So we multiply the top and the bottom by 20, and we get n over n plus 0.5 times 20 minus n, which is n divided by 10 plus 0.5n. And this is now an equation in which the only unknown is n, and we conclude that 10 times 0.824, which is 8.24, plus half of 0.824, which is 0.412 times n, is equal to n, so that n is equal to 8.24 divided by 1 minus 0.412, and this comes out to be about 14.01360544. But n is an integer, so we just take n to be 14. This is a bit confusing because the answer is supposed to be an integer. But the problem really should have said the probability of K given C is 0.832529412. And then you probably would have gotten exactly 14. Anyway, the answer is C. Please remember that this is copyrighted material. The problem comes from Society and belongs to the Society of Actuaries and belongs to the Society of Actuaries. It's reproduced with permission. The solution is mine. Good luck in your studies and good luck on the test.